Hello students, let us learn how to balance a chemical equation where we have two reactants and two products. I've taken a very common example of reaction of sodium hydroxide NaOH with sulfuric acid H2SO4. Here these two are the reactants and our products are sodium sulphate and water. Sodium sulphate is Na2SO4 and water is H2O. These are our products. Now to balance any chemical equations, as we know, the steps that we follow are we write the number of atoms of each kind on the left hand side and the right hand side. We are going to solve this equation in a single step. Now first we write the number of reactants, the number of atoms on the left hand side and the number of atoms on the right hand side of the equation. Now to do so, now since in this equation you will notice that we have hydrogen and oxygen coming at different places. It's coming here as well as in this molecule. Similarly, on the right hand side, we have oxygen coming here in the first molecule and oxygen coming here in the second molecule. Now, in such an equation, we are going to write the atoms as many times as they are coming in a given equation. That means in the first molecule, if we have sodium, we write Na. And the number of sodium atoms in the first formula is 1. We write 1. Then we have oxygen O, we write an O, and the number of oxygen atoms in the first molecule is 1. So we write a 1 for the number of atoms present in the molecule of sodium hydroxide. Coming to hydrogen, so number of atoms of hydrogen in the molecule of sodium hydroxide is also 1. So we write 1 for hydrogen. Now hydrogen is repeated again the second molecule. So we will write hydrogen again, not along with this, but we write it separately. Hydrogen atoms now in sulfuric acid are 2. We write H is equal to 2. Then we have number of sulfur atoms, which is 1 in this molecule. So S is 1. We write S is equal to 1. And the number of oxygen atoms is 4. So we write SO is equal to 4. So these are the different atoms present on the left hand side. Now coming to the right hand side, we have Na, sodium. Number of sodium atoms on the right hand side are 2. We write Na is equal to 2. Sulfur atoms is 1. We write S is equal to 1. Oxygen atoms in this molecule is 4. We write O is equal to 4. Coming to the next molecule on the right hand side, hydrogen atoms are 2. We write H is equal to 2. And oxygen atoms is 1. We write O is equal to 1. So now if we have a closer look at the number of atoms of each element on the left hand side and the right hand side, we come to know that sulfur is equal on both the sides. And oxygen is also equal on both the sides. We have 1 oxygen here and 1 oxygen here and 4 oxygen atoms here. So 1 plus 4 totals up to 5. So let's look here as well. So 1 oxygen atom here and 4 oxygen atoms here totals up to 5. And if you look at the right hand side, 4 oxygen atoms here, 1 oxygen atom here, 4 plus 1 makes it equal to 5. So these oxygen and sulfur atoms are equal on both sides. What is not equal are sodium and hydrogen atoms. Sodium atom is 1 here and 2 on the right hand side. Hydrogen in total is 1 plus 2. That means 1 hydrogen atom here, 2 hydrogen atoms here. 1 plus 2, total of 3 hydrogen atoms are there on the left hand side. And there are only 2 hydrogen atoms on the right hand side. So how do we balance this? Which atom do we start balancing first? We will start with sodium, since we need to increase the number of atoms in sodium to 2 in order to balance it on the left hand side. However, hydrogen atom is 3 on one side and 2 on the other side. So we need to increase it to a much bigger number as compared to 2. So therefore, we are going to first balance sodium on the left hand side. For doing so, we need to make it 2. So very simple to make it 2 by simply putting a 2 in the prefix of sodium hydroxide. As we know, before we do any balancing equation, we must always put a dash in front of for prefixes to any molecule, so that we know that we have to put a number only in the prefix. So we put number 2 here, as sodium is only available in the first molecule. By putting a 2 for NaOH, we clearly come to know that there will be changes in the number of atoms now. So sodium atoms becomes 1 into 2, which is equivalent to 2 now. Sodium atoms become 2. Coming to oxygen atoms also changed. There was 1 oxygen atom earlier, so now 1 into 2. Now here, this is an important step, that you make changes only to the oxygen atom present in this molecule, not to the oxygen atom present in the second molecule, to avoid any confusion. This is the reason why we have written all of them separately. So here, oxygen atom changes to 1 into 2 becomes a 2. Hydrogen atoms also changes. It is 1 here, so 1 into 2 becomes 2. So hydrogen atoms also becomes a 2. So now if we look at the equation, sodium has become equal on both the sides, but oxygen atom changes. Now the number of oxygen atoms on the left hand side becomes 2 oxygen atoms here and 4 here. 2 plus 4, 6. Let's have a look at the equation as well. 2 oxygen atoms here, 4 oxygen atom in the second molecule. This thing should also be very clear that when we have two separate molecules, number of atoms always get added. The number of oxygen atoms here in this molecule and the number of oxygen atoms here in this molecule, they will always be added. So 2 plus 4 makes it 6. So now we have 6 oxygen atoms on the left hand side, but we have 5 oxygen atoms on the right hand side. Sodium and sulfur still remain equal and hydrogen is still not equal. Total of hydrogen atoms on the left hand side now become 2 hydrogen atoms here and 2 hydrogen atoms here. 2 plus 2 makes it 4. So there are 4 hydrogen atoms. Now to compare between hydrogen and oxygen, which atom to be balanced first? Now to compare the two, we need to see oxygen atom has to be made 6 somehow on the right hand side and hydrogen atom has to be made 4 somehow on the right hand side. That means it is very clear that we need to make changes on the right hand side itself. Out of hydrogen and oxygen, we need to compare which one has to be taken. We take the atom to be balanced first as the number to be increased to the least extent. So if we compare the two, hydrogen has to be made 4 and oxygen has to be made 6. So we start by balancing hydrogen first since it is the lowest number to be increased. To make hydrogen 2 on the right hand side, the only way we can do it is by putting a 2 in the prefix of H2. Since hydrogen is available only in this molecule, this 2 and this 2, the prefix 2 and the subscript 2 get multiplied. So 2 into 2 becomes a 4. Hydrogen atoms now become equal on both the sides. We had 2 hydrogen atoms here, 2 hydrogen atoms here, 2 plus 2 equals up to 4. So hydrogen atoms have also become equal. Now by putting a 2 in the prefix also changes the number of oxygen atoms. Now oxygen atoms here in the second molecule, we are not making any changes to the oxygen atoms present in the first molecule. We will make changes only in the oxygen atoms present in the second molecule. So where is the second molecule of second oxygen atom? It is, we had written it right at the end. So this 1 gets multiplied with 2. 1 into 2 becomes a 2. So now let us see, have the oxygen atoms become equal on both the sides? So here we have 4 oxygen atoms, 2 oxygen atoms. And here we have 4 oxygen atoms, 2. So 2 plus 4, 6, 2 plus 4, 6. Let us have a closer look at the equation as well. We have 4 oxygen atoms here, 2 oxygen atoms here. 4 plus 2 makes it 6. And here 2 oxygen atoms here, 4 oxygen atoms here. 4 plus 2, 6. So this is now our balanced chemical equation. In the end, we must write it once again so that we know clearly how we have balanced the equation. So it is 2 NaOH twice sodium hydroxide plus H2SO4 gives us Na2SO4, that is sodium sulphate, plus 2H2O. This is a balanced equation. So similarly, you can try solving other equations of the similar kind very easily in a single step. Thank you.